Now we will use what we know from algebra and from trigonometry to solve trigonometric equations. And the first step will be to find a general solution. So let's look at a warm-up problem. Here we have an expression, cosine of theta, and we are told that it is equal to -1/2. So the first question that we will have is, in what quadrant or quadrants could this angle theta lie? So because cosine of theta here is -1/2, we know that cosine of theta is negative in the second and third quadrants. So therefore, it could be quadrant 2 or quadrant 3. So now as we look at 4 different possible values for theta, let's take a look at these quadrant by quadrant. So let's look at quadrant 2 first. So if we look at quadrant 2, let's look at what the reference angle would be. So reference angle would be ignore the negative and just think about what angle yields a cosine of 1/2. An output of 1/2, that is. And we know that the reference angle would be pi over 3. So now we will place pi over 3, that acute angle, in the quadrant that we are looking in. So if we look at quadrant 2, we're going to place our pi over 3 here. And so what's our angle? Our angle is just under pi. Now, in case you're having difficulty remembering what that angle is, we know that pi is 3 pi over 3. Now, if I take 3 pi over 3 and I subtract 1 pi over 3, we get our 2 pi over 3. So one possible value for theta is 2 pi over 3. But there's another possibility in quadrant 2. In fact, there's infinitely more. So we could have 2 pi over 3, but then we could also wrap around another 2 pi units, and that would yield, well, 2 pi over 3 plus 2 pi. Well, what's 2 pi? 2 pi is 6 pi over 3, so 2 pi over 3 plus 6 pi over 3 is 8 pi over 3. Now let's look at quadrant 3. So again, with quadrant 3, we can start with drawing our coordinate system and then placing our angle in the third quadrant with a reference angle of pi over 3. So in this situation, we have pi plus an additional pi over 3. So we have 1 plus 1/3 of a pi. So 3 pi over 3 plus 1 pi over 3 is 4 pi over 3. So theta could also equal 4 pi over 3. Now again, we could go around another revolution. And if we did that, that would be 2 pi added to that 4 pi over 3, which would be 10 pi over 3. Now, how many times could we do this? We're not restricted to just 4 different possible values for theta. I could keep wrapping around and do 2 pi over 3 plus 4 pi or plus 6 pi. Or I could go in the other direction. I could start subtracting 2 pi. And all of these would be coterminal with that second quadrant. Likewise, 4 pi over 3, we could do the same thing. In fact, if we look at cosine of theta, what is the period of cosine of theta? Because that's how long it will take before we repeat our cycle. And cosine of theta has a period of 2 pi. So we can take 2 pi over 3, and we can start adding multiples of that period. And we can obtain as many answers as we want. So let's look at cosine of theta equals -1/2 as just an equation that we are to solve. So as we do that, I would first look at a reference angle which we've already done, and we've said that the reference angle that yields 1/2 for cosine is pi over 3. We have quadrant 2 and quadrant 3, where our angle can reside. And we are looking at 2 pi over 3. But then it could be any multiple of 2 pi away from that. So the way we write that is we say plus 2 pi times k, where k is an integer. Likewise, if we're in quadrant 3, we have our angle 4 pi over 3 to kick things off, and then we can add multiples of 2 pi. Now, where'd that 2 pi come from? If you look back, cosine of theta has a period of 2 pi, or you can think of it as we wrap around and obtain coterminal angles every 2 pi units. So here we have 2 different quadrants. We have infinitely many solutions in each quadrant. And remember here that k is an integer. Integers are like 0, -1, +1, -2, +2, and so on. Signed whole numbers. Let's look at our next example. Here we have 2 sine of theta minus square root of 3 equals 0. So let's isolate sine of theta. So if we want to do that, let's add root 3 to both sides. And we have 2 sine of theta equals root 3. And now we can divide both sides by 2. And we obtain sine of theta equals root 3 over 2. So what is the reference angle that would yield root 3 over 2 for sine of theta? The reference angle would be pi over 3. Now let's look at what quadrants this angle theta could be in. So sine of theta equals root 3 over 2. That root 3 over 2 is positive, so sine of theta is positive in the first quadrant or the second quadrant. So in the first quadrant, if we go ahead and write pi over 3, that's not too bad. There's your pi over 3, and we can wrap around every 2 pi units, so theta would equal pi over 3 plus 2 pi k. Now if we move to the second quadrant, again we want to draw our angle in the second quadrant with the reference angle pi over 3. So here is pi over 3, and that means that our angle isn't pi over 3 in that quadrant. Our angle is actually 2 pi over 3 to land us in the second quadrant. And that will occur every 2 pi k units to obtain a coterminal angle. So there's your answer. We have those formulas for theta in the first quadrant and for the second quadrant. So notice we don't have just 2 answers. We have infinitely many answers in the first quadrant and infinitely many answers in the second quadrant. Let's look at an interesting function. Let's look at tangent of theta equals the square root of 3. So what is the reference angle here? Again, whenever we're thinking about reference angles, we're thinking about the acute angle that yields square root of 3. We ignore whether it's positive or negative, we just look at square root of 3. So we know that this is pi over 3. So where is tangent of theta? Positive. Tangent of theta is positive in the first quadrant and the third quadrant. So if I draw the first quadrant, notice what we get. We get pi over 3. And then we could add 2 pi k units. But let's hold off for a minute, because tangent and cotangent functions are interesting. So we could also be in quadrant 3. So if we draw our angle in the third quadrant, this angle would be 4 pi over 3. So 4 pi over 3, and this was pi over 3 back here. Now, I could, in the first quadrant, wrap around and go 2 pi units and go back to the first quadrant. But one of the cool things about tangent of theta and cotangent of theta is the period of these functions is originally pi. So if we took pi over 3 and I added pi, where would we land? Pi over 3 plus pi is 4 pi over 3, that third quadrant angle. So we can actually collapse these two down until we obtain theta equals pi over 3 plus pi k. And you'll see the period of our function represented right here in front of the k.